Terima kasih. Selamat pagi semua. Saya Chim Hock daripada bahagian Building Performance ataupun BVP secara short form. Ya. So tajuk hari ini, ya, terima kasih kepada MGTC bagi peluang untuk saya kongsi inovasi daripada syarikat kami dari segi mengurangkan carbon footprint, okay, terutamanya daripada peluang untuk meningkatkan efisiensi daripada central chiller plant. Okay. Okay, next. Okay. So daripada kemarin Puan Aini daripada MBBA katakan power of data. Sekarang bagi kita tengokkan dari segi data, apa yang dapat dalam data-data yang sudah dipamerkan di One World website. Next please. So if you look at here, is that where Malaysia stands, okay, in terms of the annual CO2 emissions, okay, we emit, okay, more than close to 300 million tons. Okay, next please. So let's take a comparisons, okay, from Malaysia compared to Asia and the world. These data you can get it from our world in data.org. I'll just go through very briefly, just to give everyone a relative comparisons of where we are today compared to Asia and also the whole world. Of course, jiran-jiran kita sekali juga. Okay, next please. Now, it's something as what Mr. Zulkifli Omar has said, is that a lot of these carbon emissions comes from electricity and heatings. Okay, the next thing is in fact transportations. Okay, so what I think aligned with what Mr. Zulkifli Omar has said is that we want to be, the keyword here is efficiency. Okay, now we know, okay, energy consumptions from electricities and heatings actually is the most highest consumer, okay, and this emits the most amount of carbons. Next please. So let's go into electricity in the building itself, okay. So the distributions of energy. Now during the MCO times, I'm sure every one of you realize that your electricity bill has increased because you're working from home, you turn on your air conditioning, so everybody can realize that, okay, for any commercial building, okay, 60%, more than 60%, okay, of the energy consumption actually comes from air conditioning. Okay, just now the previous slide please. Okay, and then in the factories, okay, Malaysia's, we have a lot of factories, particularly like Selangor, Penang, Johor, and so on. Okay, so cooling system in the factories, in fact, if you add these two up, is also more than 50%. Okay, so cooling system itself actually is the primary consumer in any building, commercial, even at home, okay, and industrial sector. Okay, let's take a look at next one. Okay, next please. So let's look at here is that the issue what we are facing today is in fact a lot of central chiller plant. Okay, we put it as water cool chiller system. This is your central chiller plant. If you go to shopping mall, you enjoy the air conditioning. The air conditioning come from the central chiller plant. Okay, unfortunately, more than 70% of this reported cooling system, they are not operating at this they are operating at sub-optimum level. They are not operating at the so-called green mark certified level. Okay, so like what Mr. Zulkifli Omar has mentioned is that in Singapore, they emphasize on all buildings should be at green mark, by 2030. Okay, 2025 is the next one. So all new buildings coming up, they have to comply to all this, and they put in a very stringent, okay, efficiency level. So we have to emphasize here one more time is that we are talking about efficiency. It's not just replacing your equipments, because after replacing your equipment, you are going to come to the same issue if you are not operating that at in efficient manner. So you will get your equipments into inefficient way. As you can see from here is that some of these even new systems are not operating at the good operating level. Okay, so next please. So in the industrial sector, just to update us here, okay, cooling systems takes up 16.1% and process. So this is about close to 50% of that, okay. And the total electricity consumption from the industrial sectors is 42 picojoule. Okay, next please. So this is our innovations here. What I want to share about is that we have seen so many data. Okay, I mean, those of you who works in this facility management, you understand that we have people going around the chiller plants and the buildings, taking temperatures, taking data, humidities, and so on. How do we process these data? This is a very interesting quote that I want to share. The goal for us to do is to turn the data into informations, and using these informations to get into insights of this data. Okay, so like yesterday, Puan Aini has mentioned is that how the power of data. I think this is a very good sharing that she has mentioned yesterday. And what I want to share with you here is how do we use at BBP, how we use the data that we have collected from the central chiller plant to improve, number one, improve the efficiency. Can we go back please? And keeping this efficiency, okay, over a long period of time. We understand that, equipment, mechanical equipment, wear and tear comes in, the efficiency may deteriorate. However, using the data, we are able to do a lot of predictions. We're doing a lot of, getting a lot of insight into that, and we can use that to sustain that efficiency throughout that, a longer period. Thank you. Next one, please. What we have developed is actually an analytic platform. Okay, so we gather these platforms comes in with GPUs, because we need high speeds of processing. We get in data from the chiller plants. Okay, there are a lot of information. We emphasize on anomaly detections. We detect the fault. Okay, we also use that to do predictive maintenance, and we use machine learning and artificial intelligence to monitor the status of this data, and using the models to develop, okay, different parameters for the systems to operate. So basically, as the good look at the flow here is that first we ingest the data, and then we look into, our data scientists looking into that with a supervised and unsupervised learning to train up this model, okay, and testing the score from this model, and then improve on that using artificial intelligence and machine learning feedbacks, and then we deploy that to the automations, to the system. So it's a kind of a very intensive process, and then using the data, getting a lot of insight, flowing back as a closed loop. Okay, next please. So this is basically, in summary, is an AI-based energy management platform that we use. So there are a few features that we are addressing here. Is that, number one, we address the maintenance issue. Now, once you get, let's say, for instance, you replace your chillers, okay. Now we have all these mechanical equipments, you need to look into maintenance. Now, instead of time-based periodic maintenance, we're looking into more predictive maintenance, moving away from these time-based types of maintenance, okay? And then based on that, we can use the data to improve the equipment life cycle, the lifespans of equipment, our projects, we have done that, and we managed, okay, to improve a 19-year-old chillers, okay, in today's actually is already 23 years old, and it's still running at very efficient level of 0.62 kilowatt per ton, okay. And because we are doing predictive maintenance, we are able to reduce the unplanned breakdown. So in another way, says that we improve the productivity and availabilities of the system, okay. And of course, with this going on, we also improving the efficiency. The result of better efficiency is energy saving, and we reduce the carbon footprint as a whole, okay. So how do we get the data? Okay, as I mentioned just now, you have like facility technicians going around the chiller plants and other areas collecting the, doing the log sheets, gathering all this data. But unfortunately, I think not many people actually analyze the details of that data. These are papers based, and you just keep there. And I think these are things that we do not go in there to analyze, but we keep it for record purposes. Okay. So what we do is that we automate this process. First of all, we install, okay, high efficiency, high accuracy sensors, okay, to gather necessary, informations to monitor the performance of the systems. So we have temperature sensors, we have ambient sensors, pressure, power meters, and so on. Okay, gathering all this data into our controller. Our controllers has these AI-based algorithms in there, and it's also connected to our AI platform. Okay, our analytics platform. And with that, the systems is basically processing this data real time, and based on that, based on the actual demand of the environment, okay, it come up with these parameters and modulates the systems to operate that in the optimum performance level. And with that, the end results that we can deliver with these systems is reduce energy consumptions, okay, and improved the efficiencies. Okay, next please. Okay, so this is like schematics. Okay, kind of most of you in the FM lines will understand that. Okay, this is the chiller plants. You have the chillers, you have cooling towers. What we do is that we install on these small boxes here basically these the chillers, the temperature sensors, the flow meters, parameters that we can see we need in order for us to understand the current performance of the system, and feeding this data to our controller, and from the controllers it processes this data and coming out with the optimum operating parameters to modulate, to make the system more efficient, to sustain the performance level. Next please. Okay, so we also provide a dashboard. So say, okay, and on today, what is the current performance, where are you right now, and how much have you saved in overall. Okay, so these are all real-time data that coming into your system, and that provides you with a very clear information, very clear insights on where are potential problems that your system currently is experiencing. And the systems actually provides the prompts, okay, to provides you with like alerts, something is not right, the temperatures sensors is going wrong directions, the trend is wrong. So it prompts you to take earlier actions before any breakdowns may occur. Okay. So I just want to summarize that our system, what it does is that first of all, we have an vertically integrated data acquisition systems. We integrate with, if you have an in-house BMS, we integrate with the BMS, or we install new sensors, okay, or combinations of both. Gathering this data into our controller, and then at the same time, pushing this data out to our analytics platform, okay. So the systems will be continuously looking at opportunities to improve, okay. So back end, okay, our data scientists and looking into all this data, running the programs, okay, the models that they have, and then because every building, even though you have the same types of chiller, same brands of chiller, it will operate differently. Okay, so the analytics models is with the AIs in there and machine learning is turning out different types of parameters for every building, and these informations will be fed into the controllers on site, and you get updated uh, parameters to operate in order for you to sustain. So one of the way, I mean, number 4 here, we look at here is that the systems is one of the algorithms that we will see we have implemented. Is that we're looking at what is the temperatures half an hour ago, or even 1 hour ago. If the humidity is at 90%, the wet bulb is at 23, what is the approach temperatures I should set in my cooling tower? Okay, and then it comes up with, if the half an hour ago the wet bulb is 22 and relative humidity is 97, and then you can use 1.5 instead. And we know, okay, for all mechanical engineers, the approach temperatures impact on energy consumptions is cubic effect. So that gives a very important parameters and know-how and insight to how we can monitor and control our systems. Okay, this is something that I think manually is very challenging for human to do that, because you want to use the old data, historical trending and informations, and predict what should be done next. Okay, so and we have successfully implemented these things in many of our client base around the regions. We have offices in 9 countries in Southeast Asia, including China and Korea. So have implemented in many factories. Like one of the factories in the northern side in Kedah, we have helped them to save close to 6,000 ringgit a day. Okay, next please. So as you can see, is that some of the charts that we can see from our analytics platform is that we're able to look at the health of the chillers at different. I mean, this is probably too small for it, but anyway, what I just want to highlight here is that the analytic platforms, it provides a lot of insight into your equipment health. Where is the sweet spot for these chillers to operate? They are same brands of chillers, same capacity, same year of usage. Okay, but it performs slightly differently. Okay, so you can use that to choose which chillers to operate at certain what load. Okay, and that gives you a good informations on combinations, and also giving you, like, if this chillers compares to next similar one and is operating less efficient, what maintenance or repair actions that you can take. Next, please. So besides chillers, of course, in the chiller central chiller plants, you also have the pumps. Okay, you have condenser water pumps, and you can see that, okay, these pumps, at different cooling load, different temperatures, it performs differently, from one another. Okay, so by doing that, again, you are able to know which pumps may fail in the near future, so you can schedule your maintenance to tackle the more critical equipment. Okay, next please. Okay, So you have condenser water pumps, and next we go into the chill water pump. Okay, so these are the few areas that we focus on, because these are the key equipments inside your chiller plant. Okay, by looking at the cooling tower, looking at the condenser water pumps, the chill water pumps, and of course your chillers itself, gathering all this data. Basically, I mean, I like to use this analogy is that you go for medical checkups, doctor put probes on your body for that 1 hour or two when you do your medical checkup or you run on the treadmill. But here we're putting the sensors permanently 24/7. We get the data every minute. It's better than sending a technician around every 2 hours to collect the performance data. Okay, some reading from the meters. Using this data that you have, you know very accurately, okay, what is the status of this one? How is it performing, comparing to where the systems were in the past? Okay, and the system will also, using this advanced analytics, providing you with suggestions of maintenance. Next, please. Okay, and we also look into anomaly detections. Okay, sometimes, I mean, it's too small here again, even though the chart's showing that, but it detects that it's not actually giving you the right number. So there are certain outliers from the spikes here and there. So we can use that to pick up, and then we can use that to eliminate, okay, the false alarm from the systems. Okay, so using that, again, it enhances your maintenance activity and focus, so that your maintenance teams can focus on the real issue and taking away all these false alarms. Next, please. Okay, I want to share some of the examples. I mean, these are the actual sites that we have implemented. Like back in 2014, we reduced 27% of their energy consumptions. Okay, and if you look at, I think doing one step of improvements, I would say it is challenging, but it's doable. Okay, how by you can do that by changing chillers or so on. But without replacing chillers, we managed to bring it down by 27%. And one thing to look at is that this is a 20-year-old chillers. Okay, and old chillers without replacing and pushing, bringing down that performance. Okay, by 27%. And I think the bigger challenge for us is that, as I mentioned just now, one step of improvements is challenging but still manageable. However, to maintain the same efficiency, okay, over 6 years. Today, this is already into the 7th year. They are still at zero. I mean, we brought down from 8.7 to 6.4. Today, they are running at 6.2, 0.62. Okay, and I think this is something I want to emphasize again, without changing the chillers. Okay, and today the chillers are 23 years old. Next, please. Okay, during MCO, okay, all right, we started MCO on the 18th of March. Our clients, on site, they have adjusted the operations a bit because only supermarket is operating, pharmacies are operating. So, the consumption actually dropped. So we use our analytics, study the data for 2 weeks, and then we adjust the parameters again, and it goes down. Okay, so we improved by almost 22%. Okay, further improvements by 22% from that initial setting that we have already implemented during the first 2 weeks of MCO. Okay, so that's another things, like on the 5-star hotels. Okay, so again, okay, this is like last year. Okay, this is a 1 year performance, and then MCO periods coming somewhere around here. Okay, it drops. Okay, we brought it down the performance, and after that the occupancies went up. Okay, but we still hover around below that our target performance actually. Okay, so they're still suppressing that. Okay, making that at the very efficient level. Okay, so I mean with this one I ends my sharing. Okay, next is that what we are focusing on is primarily on the efficiency of the central chiller plant, using the data that is coming out from the central chiller plant itself, the equipment from the central chiller plant, using those data, using a bit these informations that we have, analyze that in details, and then providing feedback into the systems to see how you can improve further. And one more thing is to maintain these efficiencies over long time, sustaining that efficiency with advanced data analytics. Okay, so with that, thank you, terima kasih. Okay,